Yeah, we move on to the panel discussion. I request the panelists to show their video, turn their video on. Yeah, so we've had this 3-day meeting about climate change studies. So we all agree that climate change is at least among the biggest problems, if not the biggest problem confronting humanity. And it's among the most complex problems to solve. So every day we hear sometimes dire predictions which worry us. And especially about India, we hear the most dire things being said. But over the talks, over the past few days, we've seen that there's significant uncertainty in all the predictions, especially in the regional predictions. And how to do this better is an important thing. And we all agree that the Indian research efforts needs to be significantly enhanced, and that also that TIFR could play a serious role in this. So the point of this meeting is to ask what are the specifics, like where would we exactly go from here. So, and we also know at the same time that the science should be intimately connected to policy and communication. So the point of this panel discussion is how do we go forward on all of this. So we have 5 panelists today. I'm Rama Govindarajan. I'm moderating this session. We have Professor J. Srinivasan from the Divecha Centre for Climate Change. JS, we can't see you. If you could turn on your video. And we have Dr. Navroz Dubash from the Center for Policy Research. We have met these two people in talks before. The only panelist we haven't met before is Dr. Deepthi Ganapati from IIM Bangalore. Among her research interests is climate change communication. She's recently authored a book on media and climate change. So we look forward to her comments. We have Professor R. Krishnan from IITM Pune. And we have Professor R. Saravanan from the Texas A&M University. So these 5 people are our panel. So the way we thought we'd organize this panel discussion is the following. Each speaker will be given 5 minutes to make some opening remarks. So to keep things on track, we'll have a bell which will ring after 5 minutes. So Jose will be switching on your clock when you start speaking, and there'll be a bell ringing. We won't ask you to stop, but please wind up soon after the bell. And except Deepthi, who will get 10 minutes because she hasn't spoken till now. So in your opening comments, can you also include like what are the top 2 things on your mind in this problem? So that would be important for us to know. So for example, I mean, just to put a figure in your head, suppose we had, let's say 100 crore rupees and 3 years to do this. What could or should we solve, and what would we like to solve? So this would be something if you could include, which will be nice. So I would like to ask Professor JS to start with his opening comments. Oh, wait, before that, after the opening comments, we'll have panelists talking to each other for some time, and then we will open it to the audience, both online and in real life, to ask questions, address any of the panelists they wish to. Speaker who is Navroz Dubash, maybe you can start and he can be the next person to speak. So please go ahead, Navroz.
Okay, thank you. Thank you so much. I hope you can hear me okay.
Yeah, we can.
Okay. I confess I have not very much to add from what I had said during the talk. So perhaps Professor Ganapati can take even more of my time. Really, you know, I think for a group like this, and not having been part of the conversations during the interim 2 days when you had the body of your event, I get the sense that one should actually, for a group like this, put aside a little bit the immediate short-term politics that often occupy the headlines when you're talking about the climate debate, and focus on, you know, how the world is going to change in the long run, and what scientific information is needed to address that. And I think that that really means thinking fundamentally through the kinds of information one needs. And I'm putting aside now, where your core competence is and so on, just looking at the needs, looking at the fundamental information one needs around how many productive activities are going to change in various sectors, natural resource-based sectors such as agriculture. What does this mean for forestry and coastal areas and fisheries? So various areas of livelihoods that are really important. We need to understand these things better. Now, it may well be that your comparative advantage is more looking at what we can understand of the basic science behind this and translating that into trying to figure out how one gleans from that information that then is at a fine enough scale of resolution to inform discussions around particular sectors and particular livelihood-based sort of dimensions. So, I think that fundamental science that informs how India will make decisions about feeding its population, creating jobs for its population, developing new industries, and so on and so forth. Those are, I think, the questions. Because we're not thinking about climate change right now as something that will affect mainstream considerations. We're thinking about climate change as an environmental problem in the popular discourse, and it's not really an environmental problem. It's a filter that will sort of be interposed between across all kinds of major decisions. So I would actually put the emphasis much more on that side. How does India build a more resilient society based on an understanding on the kinds of changes we are likely to see? That's a very high level observation, but without having the benefit of your conversations and hearing the others, let me start with that. I'll just make one more quick point, and I know my time is limited. If you look at I think we will undoubtedly have a conversation about whether India should get into developing its own IIM, in getting involved in sort of domestic energy and climate models and so on and so forth. And I think if we do that, certainly on the energy and climate model, then thinking better about how to internalize economic considerations like job creation and so on, but perhaps more speaking to the competence of this group, thinking about how to internalize the damage side, internalize damage functions, so you're not having separate conversations about the costs of mitigation without looking at the effective benefits in the form of avoided damages. I think we don't have enough information. We have a lot of people thinking about it will cost so many trillions to move to renewable energy and so on and so forth, but we don't have enough information on the avoided damages and therefore the benefits. And the reason for that is obvious. The costs will accrue directly to us. The benefits will be diffused, will not accrue directly to us, but will require global collective action, which is why people don't tend to think about the benefits. But really, we should, because if those benefits accrue to us, then our objective should be not just thinking about how India mitigates, but how India acts as part of the global community to push others to do more. And what is that how does India contribute to that virtuous global cycle? And for that, we need to understand what the possible benefits are of mitigation to the extent they will apply to us. And also, as the IPCC Working Group 2 report said, there are limits to adaptation. Beyond a point, you can't adapt, or the costs of adaptation will be prohibitive. So those are the two sort of big overarching points that I'll make, and I only apologize if they don't mesh nicely with the conversations that you all have had in the last couple of days. But I'm happy to come back later when I get more of a flavor of what else has been talked about. Thanks.
No, they do mesh, and it's important. So thanks for that. Okay, so meanwhile, we'll go on with the next speaker, who is Deepti Ganapati. Deepti, please go ahead.
Thank you, Rama, and wonderful 3-day workshop, and so relevant, with the IPCC report just released. Just let me know if you can hear me well.
We can.
Thank you. Yeah, so just imagine a scenario where there is a journalist or a set of media persons who have come to cover this 3-day workshop, And they're going to be going back and filing their reports. And they're going to be talking about the different scientific terminology that they have listened to during the last 3 days. They will probably have a few one-to-one interactions with the scholars and scientists here. But beyond that, how do they enable their readers to understand that climate change is for real and it's going to impact you and me, right? So while I was doing my research and while I was trying to see these linkages between what is the science, how is it being reported, and through this reporting, how do policy instruments get created, and how do they have an impact, therefore, on the field, there was a huge disconnect between these three aspects. And so that's why I think it becomes very, very relevant to make climate communication more accessible. And when I say accessible, make the contents of whatever is being researched or published relevant to politicians, relevant to journalists, relevant to climate activists, or even artists who are spreading, information about the impacts of climate change through music, through films, through books. This provides a very balanced and informed analysis of the country's environmental governance, and that can help us focus on managing the impacts of development while we stare at a biodiversity crisis. And this needs to be done with a much needed positive tone. And the positive tone, I reiterate this because for long we have considered it as a doomsday narrative. And so what happens when there's a doomsday narrative is that in the communication process, you cannot bring about the intended change or that behavioral change that you want someone to adopt, whether it is a business house, whether it is a community, whether it is the people who need to follow a certain policy directive. There is not much that can be done if there's a doomsday narrative. So how can this be done? And how can this conundrum that the media faces, because it is actually mediating between the policymakers, the environmentalists, as they unravel the multidimensional and complex nature of climate change in India. And so it's interesting that, during the course of my research, when I looked at the Western Ghats, home to around 50 million people, where there is a policy, debate happening there after it was declared as an ecologically sensitive area. And at the same time, I was just looking at other books in this time, or other lines of thought during the last 1 year at least. And everywhere there is this sense of the earth being very fragile, that, that food is climate, there is the physics of climate change, there's a false alarm. So I can see that there are a lot of these kind of books on the bookshelf on Amazon, along with, other books on climate change. So what does this mean? And how can one interpret what is happening, especially from the communication point of view, especially from the point of view of how the media communicates this, is to actually look at how the narrative of climate change needs to explore the socio-economic and cultural understanding of climate issues and the influence that environment communication can have via the news, as well as the public response to it. And so the media, we no longer talk about media as mainstream media, as print media, television. We have different forms of media today. Anybody can become a digital, communicator. They can set up their own blogs, and they can have their own podcasts, and they can become facilitators between scientists, policymakers, and the public. And, therefore, it is interesting to see how this these policy aspects can trigger a debate about development over biodiversity crisis and environmental risks in India. And why the media coverage matters is because media sets the agenda. And while setting the agenda, it uses certain rhetorical devices to frame how's the policy debate framed, or how is climate change framed in the context of a certain country. And in a way, it gives direction for public policy. For long, we have looked at the image of a isolated melting ice shelf in the Arctic, and we've looked at a polar bear standing there looking very, very sad, and we've always had that image in our mind that climate change is happening at a very distant corner of the world, and it's happening to a species that is already extinct, so it's not going to affect you and me. But today there is an increasing focus on how it has come very close home, and how we can be the next who are going to be facing that kind of a challenge. And therefore, I think it becomes even more critical for scientists, for policymakers, for communicators to work in tandem, to work together in order to bring about that change on the field level. And how can that change happen? When the process of communication becomes very clear, the outcomes are desired to bring about an action, and that action is change, which what we're talking about in the parlance of climate action. And that calls for a behavioral change where one can then adopt a way of being, a way of, we call it, we are bringing in new terminologies. Like, for instance, I teach at a business school where we think it's critical for our students and for the future leaders of India to understand the consequences of not running businesses that have not complied with sustainable practices. But beyond, mere compliance, beyond mere achieving those sustainable development goals, how can we help the public at large to internalize this entire consequence that they're going to be facing, and to help them change these practices one step at a time by changing the thought process, by changing the way in which they behave, and ultimately can adopt something. So this is where I think, I'd like to make my contribution to the panel, and then, as Professor Navroz said, we can pitch in whenever the other questions come up. So I'd like to leave, the conversation with these opening remarks.
Thank you for that.
Yeah, thank you very much for this opportunity. And actually, from the email from Professor Sandeep Trivedi, the question was how India can be better prepared in time for the next COP meeting, especially by way of our scientific efforts. This was the question. So when we say COP, actually there are two things. One is this from the science angle. This is the way I am thinking. The other is policy and more at a higher level. So first, let me give my views from a scientific perspective, how we can do better for the next time, at least. So one thing that comes out very clearly, at least in the IPCC AR6 working group 1, compared to the AR5 report, is that our attribution of regional changes has improved to climate influence. I think there is a much better focus. So the way the CMIP-6 experiments were designed and the analysis was carried out, and also the scientific publications that came out. So the regional assessment, both the attribution and the future projection is very, very strong. Even the extremes is very strong in the AR6. Also, when we talk about regional monsoon precipitation changes or water cycle changes, there is a very strong regional focus. That is a plus point. This was because of the CMIP protocols that were partly, this comes because of the CMIP-6 protocols that were designed, and all the modeling groups did the similar type of experiments. And that was one of the benefits which we are seeing. Now, when we come to the regional scales, what is the effect on the impact? What is the impact on regional scale? And also, what are the risks? What are the vulnerabilities? What are the mitigation? We don't have that much of a clarity. Still, the uncertainties are much larger compared to the physical climate system itself, where we understand better. So one of the things that we could do is we should also develop good standard protocols for assessing the regional impacts and also the regional mitigation. Just like we have for the working group, one is mostly on the physical climate system, where the protocols are well defined. Similar very robust protocols, experimental protocols must be defined even for the regional scale, attribution and impact assessments and mitigation. This is the mitigation analysis. So this is one of the things. That way we will be able to understand what are the uncertainties in, for example, floods or urban flooding. How do we estimate that? How do we evaluate this? So, or changes in the hydrology of the crop, what are the agricultural impacts? So for these impact assessment, we should develop standard protocols similar to what is there for the physical climate system. And the second thing is one thing from my experience, I found that there could be more involvement of coordinating lead authors from India. For example, when I see from China, the numbers are many more in the IPCC. So perhaps we could have, only we had one CLA in the working group 1. We should have many more coordinating lead authors from India, representing from India. This will really help. And also we had one chapter scientist, because as a CLA, I could have one chapter scientist engaged from our own center in the water cycle chapter. But we should have many more from India, because in this process, we get to learn a lot. And typically when we see the Chinese delegation, every chapter virtually has 1 or 2 chapter scientists. So the designing of the figures, how the figures are developed in the IPCC reports, that people learn. And in fact, some of the monsoon figures that have come out has been produced by my colleague Sabin. And he was greatly benefited, and it also benefits the larger community. So more active involvement of the Indian scientific community and also Indian community in general is very, very important in the IPCC process, and also in the CMIP, the modeling process like the CMIP 6. So this is my first point from the scientific angle. And from the policy angle, I think I'm not an expert. What we are projected is India has committed to about 450 gigawatts of power by renewable energy by 2030. And right now we are producing something like 150 gigawatts of renewable energy. This is latest as per November 2021. So if we can improve this, enhance the renewable energy significantly in the coming years, that will be a positive step for the next COP. This is from a policy. This is my point. Yeah.
Thank you so much.
Yeah, thank you very much.
Okay. Yeah, I'm just continuing on what Dr. Krishnan mentioned. To me, yes, it will be good to have a lot more Indian lead authors and CLAs, but that decision is highly political. I don't think it can be done easily. It requires a lot of homework by the government to make sure that more number of Indian scientists are nominated and selected to the post. So that's something which is not easy to do from our side. Maybe we have to coordinate with Ministry of Environment, Forest and Climate Change to find out what happens, because they do nominate names for all chapters. But in the selection process somewhere, I think we do not have the clout that is necessary to ensure that there are enough number of Indians in various chapters. So one has to understand how that works and get into that. But I can tell you there's a much more fundamental problem in India. I remember that from the first IPCC report up till I think the fourth or fifth, the Indian government did not take climate change seriously. They thought it's a problem of the developed world. They have to find a solution, and we don't have to do much. So I think that has changed now, but still, the government only has changed. This problem is primarily a developed world problem, which they have to find ways to, I think, But now I think this is realized that India has to play an active role and also demonstrate the seriousness to mitigate climate change. So that change has to occur. And one of the things I remember in the first PRPC report is that when the government of India was asked to give the feedback on the report, they didn't give much. It has improved now. In the last 2 years, there is a feedback, but there was no detailed discussion on the draft reports and feedback. And so maybe the feeling in IPC was that India was not interested. So India has to engage itself more seriously at the higher level to be able to get their scientists incorporated in the as LAs and CLAs. So to me, that's one issue. The second thing is I thought that this meeting was called primarily to find out what ICTS can do. Is that not the main purpose of the meeting? Am I right?
Yes, yes. What TIFR can do in general and ICTS.
Yeah. So to me, having gone through all the talks in this workshop, and there were some very good ones, it's quite clear that ICTS has a lot of expertise in complex systems. And Earth is a complex system. So they should be able to bring their knowledge and skill to look at some of these problems. And especially in the area of nonlinear system, based on the talk given by Professor Arvind Seshadri, people in ICTS should have some idea of what is going on in this field regarding climate change, and they should be able to see whether they can bring their expertise to work on some problem and provide new insights about the nonlinear phenomena in climate change. Okay, that's one thing I think I clearly can see a lot of new work that can be done. The second one is what was discussed today, which is related to AI and machine learning. There's a large amount of data coming in, both in observation and from models. It is good to be able to examine this using these modern tools. And here also, I believe there is expertise within ICTS to look into some of these issues and see what insight they can bring into interpretation of data from observation, proxy data, as well as model output. That's, I think, another important input that they can give. And lastly, I think there is a need for more interaction among various institutes in the country, informal interaction, so that we as a group can go to Ministry of Environment for the climate change to give an input. Right now, the way these discussions about IPCC are conducted, it doesn't involve many institutions. So we must find some mechanism by which all the institutions interested in climate change can get together and discuss among ourselves, and then go to the ministry and tell them, this is what you can contribute. So I think that part, we have to be proactive, because the ministry goes through each procedure to identify scientists to get a feedback. But I think it's important for us to be proactive and say that these are the institutions who may be able to contribute to a discussion on climate change.
Thank you.
Yeah, thank you.
Professor Saravanan.
Hello. So I'm a climate modeler, and for many years, like 30 years, all I did was to write computer programs and write papers, and I thought, well, I'll just publish the results, and the information will propagate in the right direction and reach the right people, and people will make the right decisions. And it's probably true in many areas of science that works fine, but I realized in climate that's not quite the case, and there's a lot of loss in translation as the information propagates. So let me give you a few examples. I've studied abrupt transitions. I've worked on the collapse of the thermohaline circulation. The people who work on the collapse of glaciers. But the word collapse means many things. A geologist, if he sees something collapsing in 1,000 years, changing in 1,000 years, they would call it a collapse, because they think of million-year timescales. by the time it gets to the media, it gets to be that the glacier is going to collapse or the Greenland ice sheet is going to melt in 10 years, which are physically impossible. But usually the original scientific statement is accurate, but some adjectives and qualifiers get dropped by the time it gets published. And the problem is that once it's published, the journalists can't refute it because they don't have the expertise to refute it. It has to go back to the scientists to refute it. And so scientists can't completely avoid the media. And many scientists in the US are getting active in just refuting exaggeration in both ends, with people who exaggerate there's doomsday and people who exaggerate saying there's nothing to worry about. And battling exaggeration at both ends, it's ended up being the domain of scientists because of the loss in translation. The other issue is like there's a 1.5 degree target that people are working towards. And there are people who panic, think, what if we reach 1.6, 1.7, will the world end? It's completely not the case. And but there is this myth that we'll suddenly collapse or civilization will collapse in 20 years. Or again, all those myths, sometimes threats motivate people, but if you exaggerate it, then it demotivates people. And as Deepti pointed out, if you want people to act rationally, you want to get the threat at the right level. And that's a hard thing to do. And the other thing is how information from scientists gets to people who need it, like planners and so on. And I was talking at lunchtime about a McKinsey report, which I was watching a wedding in India from the US, and the wedding was in Madurai. And the pastor talked about God, and then he talked about the McKinsey report and what climate change is going to do India in the same sermon, okay? He was putting McKinsey report on par with God. But then he said, you're going to get heat waves that you've never seen before, and India and Pakistan, you can't live outside in 2050. And so I went back and Googled the McKinsey report, and it was based on scientific models, but it was based on a particular scenario called RCP 8.5, which is the high-end scenario. And it based on a particular interpretation of that. And that was considered business usual at some point. But if you look at the latest IPCC report, it's a weaker scenario called RCP 4.5 that is considered more likely. But there's still, but all this information gets lost. 4.5 or 8.5 doesn't mean anything to a normal person. And so people need to know that there's a range of outcomes, and which outcome you focus on depends on the risk. I mean, for certain risks, you might want to look at the worst case scenario, but for certain risks, it's probably too expensive to do that. You might want to look at a mid-range. And if you lose that information and focus on one particular scenario, you make the non-optimal decision, which could be expensive. So there's a lot of information transfer. Dr. Dubash talked about it, and it's often missing how to get the information to the people who need it. And it's an infrastructure to do it in a reliable way, keeping all the options open and saying how to pick the best option. And sometimes the originator can't pick the best option. The end user has to do that. And they have to get all the options laid out in an accessible manner. So I think it'd be good. Every country faces this problem, and I think it's probably especially a problem in India. And trying to help address that, even though I'm a scientist, trying to help work with other people to help address that is sort of my goal in participating in this.
Navroz.
Yes, it's not a question, but a comment, I think, in reaction to what Professor Krishnan was saying. And also, I think, in response to the question of IPCC authors. The IPCC is, as JS and others know very well, is an extremely strange beast in that it is meant to be a scientific process, but it also has its credibility rests on reputation for even-handedness and geographic representation and so on. So a lot of times in these chapters, you will have, for example, in my chapter, we have, I think, some 11, 12 authors, but 90% of the work is really done by 4 or 5. And there's a real balance in energy levels, skill, time, reputation, and so on. Not to say that a younger person can't be productive or an inexperienced person can't be productive. They can often be very productive, but the willingness to work, the range of knowledge they bring is very variable. I think over time, it probably is worth trying to sort of broaden Indian participation in the IPCC, but I think at the core, it's really providing, it's for Indian scientists to be aware of how the IPCC scans information. So you've seen in the last few years, a real concentration of citations, at least in the policy side of the IPCC, which I know better, the Mid-Working Group 3, where there is a subset of authors who kind of know what makes for a very quick and easy citation. If you are doing a comprehensive and systematic survey in a well-published journal, then all you have to do is, as an author, you pick up that survey and you pick out, 2 lines, so 2 summary lines from it. People write their abstracts in such a way that lends themselves to that. And then you can give it a high confidence statement because it's based on a systematic survey of so many hundreds of articles or thousands of articles or whatever else it is. And the findings will be written in such a way that that's possible. So there's almost a game here of how you multiply your citations within the IPCC. Not saying that we should be playing that game because some of it is not very ethical, but we should at least be aware of how authors select and scan articles. And in particular, how we get good information in on South Asia and regional effects. So understanding that process, especially for younger scholars and having more experienced IPCC authors explain how that works, I think could be actually just a fairly simple task, but a useful one. Second comment I want to make is about how India puts its objectives, its NDCs forward, and we talked about the renewable energy target and so on and so forth. Now, very often these targets, in my opinion, are driven by political considerations that are not very well backed up by analysis. So, India's original 23 to 25%, I think it was, intensity target was on the basis of a 3-page note from a think tank, which did a simple elasticity calculation. The 500 gigawatt target, the Central Electricity Authority was asked to do a study of it after the target was announced. In fact, the 450 gigawatt target was announced. And the fact that we are talking about capacity targets itself is deeply problematic from an electricity policy point of view, because it allows the government to provide incentives for building renewable electricity capacity, and simultaneously stimulate banks to provide funds for new coal mines, actually keep on going with thermal power projects, and so on. And the risk is that from an electricity point of view, who is going to buy all this power? And you really face the risk of having stranded assets, because either the coal side or the renewable side may end up being unused or used poorly or not fully. So there's no incentive to actually think about how you're balancing your coal and renewable assets. So the formulation of that target is not actually, in my view, in the interest of the Indian electricity sector. We should not be blindly adding capacity. We should be trying to enhance generation from renewable energy, which is a more complicated and a better way of sending policy signals. So too often we don't have our homework done before the political pressure hits. To give you an example of the net zero story, we were adamantly told that net zero is not on the table for India before COP.
Can you put you're taking your phone?
Dr. Srinivasan, we can hear you now.
Okay.
So we were adamantly told, so there was no analysis done really for net zero. A couple of think tanks did something, but there was no government-sponsored analysis. So a net zero target for 2070 was made without a single official modeling study really having been examined. So, we have to have an analytical work in place well before, which means that the network from the ministry to research bodies has to be well established. And those links are not well established. So, I was at a meeting with China once where the Chinese colleagues had 4 or 5 different modeling results, all of which were placed before their ministries for discussion a year before any political decisions were taken. We are a long way from that.
Thank you. Those are very revealing and, thought-provoking points.
Rama, Yes. I wanted to respond to what Professor Navroz Dubas said. Regarding the confidence statements, my view is because at least in the working group 1, I'm not sure about the working group 2 and 3. I'm not qualified. There were very clear guidelines how to, because the multiple models have gone in, So when you evaluate, they give a high confidence or a medium confidence, how to do, whether it's a temperature change or precipitation change. The guidelines were very, very clear. And so I would not say that it is, I believe that the assessment is fairly robust, at least in the working group 1. And also across the chapters, there is a cross consistency. And it goes for peer review. Several rounds of review happens all over with the governments, with the scientists. And so even assigning a medium confidence or low is I mean, a lot of work goes into it before it is, confidence is assigned to that. And so I would not say it is entirely, it is done arbitrarily. That is my at least for the working group 1. And I was very closely associated with the chapter on water cycle, and where we assessed droughts, and droughts was also assessed in the extremes. And we made sure that the statements are all they are consistent, and the comments, and all the comments have to be responded. So for typically the first order draft, second order draft, third, so all comments have to be responded. And we cannot have a blank response. So the assessment process is fairly rigorous, quite rigorous, I would say. So that is my one point.
Thank you, Dr. Krishnan, for that important response. Who would like to go next? Yeah, JS, would you like to say something? You started speaking. He's frozen again. Yes, Navroz.
Yes, thank you. So I just want to very quickly, if I could, just follow up this conversation with Professor Krishnan. I certainly don't mean to imply that the process is not robust. I apologize if I've given that impression. What I was trying to convey, I think, is that I come from working group 3. A lot of these norms were devised for working group 1, because when the IPCC was set up, the question was, how do we have confidence in the science of climate change, and is this problem actually happening? The same norms have been applied to working group 3, where the kinds of information that are brought out are often quite different. I'll give you one example, which is an active question for us right now. How do we talk about the costs of removing fossil fuel subsidies? Now, this is a very politically charged question. Obviously, the oil producing countries take this very seriously. They oppose statements about the need to reduce this and so on and so forth. So a range of studies have been done, and they find that the cost of reducing it to the economy, that in fact there are net gains to reducing it to the economy, but that range between 1 to 10% of GDP. Now that's a very big range. And there are only a handful of studies that try and do this. Now, as an author, when you're assessing this, figuring out whether to put that as a low, so it's medium evidence, because there's 5 or 6 studies. It's not 1 or 2, but nor is it 10 or 20. And it's medium agreement because the range is so big. But that is a judgment call. And there's a very big difference between medium agreement and high agreement politically. So we have to make those sorts of judgment calls all the time, is the point I was saying. And people who are savvier about how the thought process works are able to write their papers in such a way that make that judgment easier for the authors ultimately making it. So that was my point, that involvement in the IPCC helps you understand the decision-making process in ways that then shape how people write their abstracts.
Yeah, just one point. Yeah, of course, in the approval session, the governments can always, so during the review process, one can always question but how this was arrived to. And so there is an opportunity whenever we are having a doubt or a concern about a particular confidence statement. I think we should, it's our responsibility to mention that, please explain, please clarify this. And also during the approval session, we have to raise this issue, that how this has been, because in working group 1, I remember Saudi Arabia where they were very, very strong on certain confidence statements, even in the working group one. And so our negotiators also, we have to be very, I mean, we cannot give up. So we have to really put forth our point during the approval session. And in fact, they did a good job from India this time in the approval session.
I had a question for Professor Krishnan. You mentioned that the regional changes have improved, significantly. But for a country like India, where there is so much of, diversity, how does it fall into the much larger, scheme of things that the government wants, while having these negotiations, so that it, clearly goes back and aligns to that thought process that they want to do. So how do they factor in these regional imbalances while showcasing what they want?
Yeah, I get your point. What I'm saying, when I say the regional assessment has improved, question is, how do you define regions? That is the first thing. What is meant by a definition of a region? So there is some clarity in the working group one on the physical climate system when we are talking about regions. It could be typographic region. For example, monsoon could be a typographic region. It could be a mountainous region. It could be a coastal region. So this definition exists in the working group one. A similar kind of classification when we are talking about the impacts, I'm not sure how good they are when we are talking about at the regional scale and sub-regional scales. I think it has to be evolved. Then only we will be. So these are the big uncertainties I was referring to in my first part. So yeah, from a working group one angle, I was telling. So the regional assess attribution has improved.
Okay, understood. Also, to add on to, you talked about this, the visual representation of, how it is conveyed. And I could relate very well to that because increasingly in the media also, there's a lot of now app-based devices, where you can feel the heat in your city, or you can, have a very interactive process of how climate change is affecting you, because we are dealing with the millennials, and the millennials like to have everything through technology. So increasingly journalistic practices in covering climate change have moved from, just projecting it as the scientific community gives it to them, to using their own graphics and, making very interactive graphics and kind of, also bringing in that element of interactivity to show these differences. It could be 20 years back to how it is now, or it could be change in crop patterns, or it could be the number of catastrophic events that are occurring worldwide. So I think, the way in which the visual representation happens also can significantly impact the way in which the communication takes place, because pictures are much more depictive, and what you choose to place there also matters. So I could completely
absolutely. In fact, there is one of the important aspects, innovations in the AR6 is the interactive atlas. Okay. One can go and click on the region. You can get time series. You can get spatial maps. That is a very important innovation. And they also have a climate impact driver that is also assessed for different regions, and also global climate impact drivers. So these are all very key innovations that have happened in the working group one. So my suggestion was that involvement of the Indian community in these processes of the IPCC will be very, very helpful. In fact, when we brought out our regional climate change assessment report, Professor JS was one of, he has gone through the report, and he has written the foreword, and his suggestion always was, Krishnan, focus on the figures. They are going to be very, very important. He kept telling, and that has really helped. So, yeah, thank you very much.
Saravanan, you were talking yesterday, in your talk about, climate being the study of everything, and you qualified it nicely by saying you should, it's a study of everything that is important. So would you like to comment on it in view of practically the bewildering array of things that we seem to be grappling with over here.
Okay. Okay. I don't fully understand that, but I'll try to address that.
I'm asking what can we leave out?
Okay. Okay. As a modeler, one of the things that is when people first started modeling climate, they were focused on the global mean temperatures. Okay. And the goal was mitigation. You don't want the temperature to exceed 1.5 or 2 or something. And modelers worked hard to get that number right. But I think we're past the stage that we can get, the latest AR6 report narrowed the range as much as more than any other previous report. The climate sensitivity was narrowed. I don't think we're going to do any better than that for global mean temperature. And mitigation policy is often driven by global temperatures, trying to in a safe threshold. But what's going to happen in the next iterations is more adaptation-related things, because mitigation policy, we have enough information for mitigation policies globally, and we're not going to get better information. The climate sensitivity is not going to get much narrower than it is today. And improving our models to get that number narrower people do it for science reasons, but it's not going to affect policy. But what is important, as Dr. Krishnan mentioned, is regional information and regional planning, and how we can improve the regional predictions, and not necessarily into 2100, but in even a shorter time horizon, 20 or 30 years. And there, the model improvements probably will help the most. Getting the mountains right, it rains differently on different sides of a mountain. And if you want to get the mountain right in the model, so that's where a lot of our modeling effort is going to be focused. And so in Rama's question, what is important? In climate modeling, global mean temperature was very important, but it's going to be less important in the future. What's going to be important is the rainfall pattern in India or those kind of things in different regions, and trying to get a better handle on that. Shorter time horizon, I think that's what's going to be important. And to some extent, we were talking about aerosols in this meeting. Aerosols make regional impacts, and how aerosols may affect Indian predictions of rainfall and pollution. Pollution is a big issue in India, both climate change and just daily life. And those things, regional impact of pollution, which will be in the same model as a climate model. To study that, I think that's where we're headed. So I want to change tack slightly, and following up on, and I think Dr. Dubash's comment that people need information. I'm a scientist, and one of the things the problem is that some of the things that need to be done involve work that can't be published. I mean, making it easy for people to access information. Scientists face this all the time. If you write an op-ed, it doesn't actually count towards tenure, for example. Or if you're helping people process regional climate information, it's not publishable. But scientists need to be involved in it. How do you reward scientists for that? That's because if you take scientists out of that, then it doesn't work so well. But the powers that be have to have a mechanism where they fund activities which are not traditional science, where it's a 3-year grant, you write papers and you get promoted and you're rewarded that way. But having a mechanism where outreach and developing this app that people can see climate change visually, how is that rewarded? So that's a challenge for the funding infrastructure.
Thank you. So JS, I had a question for you, if you can hear me. There are no immediate things the panelists would like to say to each other. Maybe we can open the floor to the audience. Yeah, I would first like to ask Rajesh to say something about the TIFR or ICTS perspective, if you can.
TIFR, I think we should have people who are looking at it broader say something. From ICTS's point of view, I wanted to say one thing which will actually lead to a question to the panel, which is, I mean, we are an institute which has capabilities in the theoretical mathematical sciences, complex systems, as Professor Srinivasan mentioned. And we definitely would be wanting to make an impact through those areas to the science of climate change. Also have a very active outreach program, and we hope to be able to.
Okay. I think now I believe now that my mic is working.
I can hear you. Yeah, please continue.
So we have an active outreach program in which we would try to, of course, also help in the science communication of climate change, and also finally through programs like these, which I think we are very committed to following up on, and bringing together not only the national community of scientists, policymakers, and so on, but also around the world. We are happy to facilitate that process in whatever way we can. But we are coming back to the first point, namely about the way in which we can contribute to the science, which I think is one of the questions that the whole TIFR system would like to kind of identify. So I would like to ask the panelists, are there glaring holes in the Indian system as far as the science goes, which are not being adequately addressed? I mean, I'm a complete outsider, but I was told, for instance, and I think there has been some discussion, that assessment of hazards at a regional level of climate change, but let's say, I'm just throwing it out as an outsider, let's say in the Kaveri Delta, how will, in the next 50 years, how will the rice production get affected? Or maybe in Uttarakhand, or in the Western, or what are the chances of Bombay being flooded, experiencing catastrophic floods in the next 50 years? So are there things like that which are sort of fairly local, but of importance? I think people mentioned about impact assessment, and but to understand that, I guess you need to have a way of estimating probabilities of such events. So I was just throwing that as a question of perhaps one area which maybe no one in India is addressing, or other areas involving bringing in computational techniques, which machine learning, of course, was mentioned, but other computational techniques from the hard sciences, which may play a role in addressing some questions in climate science, especially relevant to India. So as you can see, these are somewhat vague and not precisely formulated, but if there's any response from the panelists, I would love to hear.
JS, would you like to respond?
Yeah, can you hear me?
Yeah, we can.
Okay, good. See, let me tell one major problem we have in India, which I want Krishnan to respond to. See, normally climate change is looked upon as the impact of CO2 doubling, for example. Okay. Now, that cannot be used to look at climate change at a local level, because local climate change depends upon CO2, land use, aerosol, and urbanization, so on. In India, there is no differentiation with these two things. And most state governments put out district level climate change scenarios in which they don't take into account land use, land cover, don't take into account urbanization, don't take into account air pollution. So I would like Krishnan to comment on this.
Yeah. Thank you, Professor JS, and also Professor Gopakumar. So my response to Professor JS and also Gopakumar, Rajesh, is the same, similar. When we are talking about regional attribution, now why is regional climate, we get a big anomaly either in temperature or precipitation? How to attribute it to climate change? Is it because of human influence, or is it natural, or is it because of greenhouse gas, or is it because of aerosol or land use change? This is a very, very challenging attribution problem. To just give one more example, Uttarakhand, we had a very heavy rainfall in 2013, beginning of June, I think June 16th or something, unprecedented rains, something like 200 millimeters of rain in a day, 200, 300. So several locations of Uttarakhand, and that led to a major flooding. So when people ask whether this is because of climate change, can we attribute it? It is not a straightforward problem, because at the same time, we had a low pressure system going from the Bay of Bengal, and there was a very deep trough mid-latitude coming right from the extratropic. This pattern, there was in fact a blocking pattern in the atmosphere, and this trough was persistent. So the interaction of this mid-latitude and this mid-latitude trough and the monsoon low pressure system, there was a lot of moisture being supplied into that region, and it was flaring up this convection. And there are several studies. Now the question is, if we want to do an attribution to human, so this is called an event attribution, a specific event where you want to attribute. Probably climate change has played an effect, but how do we do? We don't. The state of the art still has challenges in doing those kind of events, and especially if you want to simulate something like 20 centimeters, 50 centimeters of rain in a day, I think the models are still not there. And and also the question is in the future whether it can happen because of the rate at which the moisture is increasing with rise in temperature. Potentially it is possible, but we need to still the capability to improve the models and predict and do the regional detection and attribution. We are still far away, and that is one area which we really need to focus and that is going to be key for even future projections of extremes. Maybe for the temperature extremes we are kind of better off, but precipitation extremes are going to be very, very challenging. That's an open topic of research.
If I can just quickly ask a follow-up to that. So what kind of skills are needed for making those assessments?
Yeah, the skill is because this particular example which I gave, it depends on the flow, the type of atmospheric synoptic situation that existed at that time. So how do you isolate the effects of this atmospheric dynamics versus the effect of the climate change, and how to do the attribution, how to separate the signal, how do we bring out the signal and separate it from the noise? So that is the internal variability in this case. That is the real challenge. And of course, models have to improve, and we need to do large number of ensembles. It cannot be, the number of realizations that will be needed is more. And the models are just not, for example, if I want to simulate 50 centimeters of rain over a location, the models are just not capable. Maybe with the use of new techniques like the AIML, probably, and with more data being available, I see some prospect there. We may be able to improve our extremes. And also increasing the resolution may help to some extent. So, but a lot of understanding is needed still. That is what I would say.
Thank you.
Krishnan, can I add something?
Yes, surely, Professor J.
Yeah. So one thing, there is a paper published on the Uttarakhand event. You remember that, right?
Yeah, in fact, we published one or two. We have published a couple of papers
on the attribution.
Not on the attribution. Not on the attribution.
Yeah. There is one paper on attribution of Uttarakhand claiming that one can show that it occurred, I think, 7 times more than because of climate change. So the point is that you are right. You have to do a lot of ensemble runs to get that result, and that can only be done at IITM. No other institution can do that kind of ensemble run where you have to do many runs to demonstrate, right, the impact of doubling CO2, for example. But my concern is, if we want to really do regional attribution, where is the data on land use, land cover change? Where is the data on local air pollution to put in the model? To me, that is the biggest gap in our data. I mean, how can you do without putting all, for example, urban heavy rainfall? You have to put all the urban urbanization factors. I don't think they are there. Suppose you want to know why rainfall in Bangalore increased so many times, you have to put all the built-up areas into the model. Is the data there with IITM to put all those information?
Yeah. So my response, my thinking is definitely the changes in the land use, land cover. It is important in terms of, for example, flooding impact. The impact of heavy precipitation itself may be determined by the atmospheric dynamics, the thermodynamics, and so on. So changes in the greenhouse gases and aerosols and those atmospheric processes and water vapor, that is going to dominate. A land use land cover also, I'm not denying it, but the impact of land use land cover changes will be more profound on the flooding. Suppose there is a heavy precipitation event and you have a scenario where there is not much urbanization, and another scenario where there is total urbanization. So the runoff and flooding is going to be very different depending on the land use land changes. So in terms of the impact itself, it's going to be very different. But to what extent it is affecting the precipitation, it's a much more challenging problem. How land use land cover is going to affect. So that's a very, very challenging question. And of course, data is also not there to that extent. Yeah.
Right. Sandip?
So first of all, I would like to thank all the panelists for a very engaging discussion. And I wanted to just share this thought with you all. You know, hearing everyone through the 3 days and today what was said in the panel, it seems to me that it's not gaps, we just haven't built the networks, to go back to a phrase that Navroz used, in various aspects, where climate science connects to impact, where it connects to policy, where it connects to communication, and so on. And so what I wanted to ask you all was to comment a little bit on how we could go about creating those impact, that kind of network, sorry. And I'll just say one thing in my mind, as Professor JS said, the science community needs to organize itself. I've seen this often. We don't work in it. Ideally, the government of India would say, do this by way of organization so that scientific information will flow to us appropriately, as Navroz said, when we go into the COP negotiations. But I think we have to organize ourselves. But as to the extent possible, we could build that network with the government in collaboration with policy folks, and if possible in collaboration with the government. So that's one example. When it comes to communication, similarly, how do scientists, whom do we get together with and build that network deeply? And of course, Navroz will, please do tell us more. You alluded to it, but please do tell us more how to do it, and also Saravanan. So that's my general question for everyone. And then my request to ICTS is one of its goals being to I think, help build the Indian community, is maybe we can take forward this process of building networks by bringing people together. Okay, so that I just wanted to throw it out there to get your views as we go.
Before you respond, let's have comments from Spenta on this as well.
Hi, thanks everybody. It seems to me, as I think Sandeep also mentioned, that there is a triad here of science and policy and communication. So regarding this issue of bringing people together, I just wanted to, can you hear me, everybody? Can you hear me? So I was just saying that there is this issue which is raised by many people all the time about how to put people together, actually, to be able to do climate science, amongst other things. And Rajesh has pointed out that ICTS certainly is a forum that can be used to do many things about this important problem. There is another initiative which I wanted to talk about, and that is the cluster initiative of the Government of India, which many of you may know. So there is an initiative to set up science and technology clusters in various cities of India. And there is one in Bangalore. And the objective of this cluster-driven framework is to create collaborative ecosystems. And clustering these organizations, which usually don't speak to each other, together into one shared ecosystem. And this is an effective method to leverage pre-existing pockets of strength and benefit from the untapped strengths of collaboration. I was just reading out a slide from some time ago. So this initiative is there. And in Bangalore, one of the themes of this initiative is climate and weather science and monsoon. And Rama is actually involved in a very deep way in this, which brings together 14 institutions in India and approximately 20 principal investigators to come and work on various issues of climate science, including policy, including communication. Rama, may I invite you to actually say a few words about that?
So yeah, it's a very ambitious program where we've asked, people to do things like, we've asked to do things like even take ships out to make measurements in the Bay of Bengal, in the Arabian Sea. We've asked for, a small, we're designing, actually IIT Madras is designing this small drone. So as we've seen over the last 2-3 days, like clouds are a very important question mark, right, in climate. And because we don't know enough about clouds, we're not able to, the models are not able to perform well. So one of the things is that you need to make direct measurements inside clouds. And the only real way to do that is through little drones. So IIT Madras is designing one such drone, and we would like to fly it into the cloud. It cannot fly too high, but it can measure low clouds and actually get information, which is going to be very useful in cloud microphysics that you've been hearing about. So there's a range of ambitious things like this, where measurements will go hand in hand with simulations, and they'll go hand in hand with theory. So 14 institutions have come together to make this group up. So where it will go in the next few years, how they will talk to each other remains to be seen. But I should also add that there are, private companies who want to make small short-term predictions, who are involved in this. There's also people who want to study river basins like you were talking about. So a very wide-ranging, kind of subject grouping is here. So that is what I'd like to say about this climate group that we're trying to put together. Yes. So
two people with hands up there.
Yeah, so there are 2 hands up. Deepti first.
Okay. Yeah. So to answer the questions that were posed by the audience, I think it's very important to be a very publicly engaged scholar. And to give you an example of that from the last 2 years, when the pandemic hit us, it has been very interesting to see how these researchers, especially the medical practitioners and researchers in the US, have been so vocal about what vaccine they advocate, or what are these symptoms to look out for, how the variants are playing out. And this is something that was, playing into what we are also discussing here, which is risk communication and also the uncertainty about not knowing how the things are going to evolve. So there was a lot of, these people who took to Twitter, experts, whether it was pharmaceutical experts, medical practitioners, researchers, who took to Twitter. They started their whole own, handles, and they refused to let the media be the gatekeeper of that information, right? They started, getting a lot of interest, and there are a lot of scholars who kind of vouch for their credibility now and say, we follow their advice about what vaccines to take and, how to stay protected during a particular wave. So I think it's very important for climate experts and scientists to become more vocal and to engage publicly through the different social media platforms that are available. For instance, you will see a lot of groups doing podcasts and a multitude of things, but it's also very important not to get lost in doing all this, and that you must have a clear goal of how it should reach the policymakers. Like, for instance, Twitter is where policymakers, government officials, everybody is there. So there's a lot of networking that you can do there. But also remember that, there is the mainstream media also, like you said, op-eds don't get you a tenure, but it's important to have that kind of a writing going also that makes sense in a very simplistic, clear and lucid manner. Because having taught senior bureaucrats and having, seen how mainstream media articles are perceived by the policy writers as well as the decision makers, it's important to have that coming out consistently, and in a voice that is, very, very decisive, and you're arriving, there with a very firm conclusion. So it's very important to keep doing that. And also, as you asked for some suggestions on how the networking can be increased, I can definitely speak about it from a business point of view, because I teach at a business school. Today, corporates need to move beyond the reporting of ESG, sustainable practice and compliance, and achieving the SDGs, but they must be able to actually understand what's happening. So here's a chance for you to collaborate, whether it is the oil and gas industry, whether it is the shipping industry. Here's a chance for you to collaborate. For instance, I attended a conference on sustainability by a big textile manufacturer, and I never saw a single climate scientist in that 3-day conference. So, there should be greater interaction with these big business houses, because they are the ones who are trying to seek out more information and trying to also incorporate that in their business practices, and that can have a significant impact. And thirdly, I think you need to, build communities. Like I'm a big advocate of the indigenous wisdom and what communities can, how they can give out wealth of information. So some amount of qualitative, research finding through focus group discussions, through going out there in the field and having one-to-one interactions with these communities can be real indicators of climate change. For instance, when I was doing these focus group discussions in the Western Ghats, speaking to the indigenous communities there, I asked them, how do you perceive climate change? And they said, oh, we watch in the television, in the news, we watch these big cities getting flooded and there's a deluge of water on the road, and that is climate change. So, the way in which they perceive climate change is very different. While it's happening right there in the forest, there are different ways in which they can perceive climate change. But for them, the way in which the media is portraying it, happening just in the capital city of their state, is climate change. So it's important, therefore, to tap into that indigenous wisdom and to, see the linkages. For instance, one big impact of climate change is going to be on health. And we have already, got an inkling of that in the last 2 years. So as extreme climate events occur, we are going to be in for a lot of health problems. And that's going to have an impact on the most vulnerable communities. And also it's going to have tremendous impact on the socio-economic conditions as well. So there are these linkages, and there is this effect that's going to be felt. So it's very important, therefore, to one, become a very publicly engaged scholar. Two, build your own, communication channels, understand what channels work, and how to therefore keep the communication going there. And thirdly, to tap into this indigenous wisdom and have more qualitative kind of inputs coming from the field. And that's really what, I think TIFR can do going forward.
Thank you. Navroz?
Yes, thank you. Just one quick observation going all the way back to the attribution science, which is that it's very interesting, but the attribution science has opened the door to several cases around the world of direct climate litigation, where people are filing cases on the back of those findings from attribution science. So it's a much straighter than normal line from science to policy, where these are actively being quoted in cases, and judgments are being made substantially on the basis of this in a number of countries. So I just want to sort of flag that. In terms of the questions about networks and so on and so forth from Professor Trivedi, I mean, again, I'm on weak ground. Much of this was already happening. I certainly know, I'm only dimly aware, but I believe it's certainly the case that IITM in particular and is very actively engaged in all sorts of conversations to sort of spread the work that it is doing. So
Thank you.
Hi, I'm Alok. I work at Google. Hi, Navroz. I think we've seen you before. So a couple of comments on this discussion, and sorry if I haven't attended the whole session throughout the 3 days, but a couple of points. Professor Krishnan and Professor JS, for land use, land change, let's talk. I think we have some models that might be very useful. They're global and at 10 meters and potentially useful. They're still very early, and so much of the work is not published yet, but we are doing early pilots. Around the other comment you had around aligning incentives for scientists doing sort of work that doesn't lead to publications. So from my perspective, climate change is going to be the largest investment that all of humanity will do to completely transform to a zero carbon pathway. And so there's 3 components. There's policy, there's finance, and there's technology. And in part of technology, there's 2 sides. There's fundamental science, and then there's actual industry being involved in scaling things up. And so I think industry has a big part here to play, where they can help align incentives such that, think about sort of trying to build profitable business models. Climate change can't be seen as a philanthropic effort. There has to be a pathway to make a business out of it. And only that is a pathway out. I agree around standard assets and energy investments that the government has been doing. Another question was around, I think Professor Rajesh had some comments I have there are sort of building sort of fundamental progress towards sort of better remote sensing and machine learning, sort of having like global leadership in this area would be very good to have from academics in India, particularly because the other pathway of having large-scale IoT deployment is too expensive for India. Whereas remote sensing is on the Moore's law pathway, where launching satellites is getting cheaper and collecting data is sort of like higher quality and lower cost quantity.
So that's one comment. And then the other thing is, I think solar geoengineering might be another pathway where ICTS could do some fundamental research, because this is a potential gamble that the world will play one way or the other. And there are serious implications for monsoons and other. And so this may be something that only an institute from India should be spearheading. Solar geoengineering is a high-risk, low-cost pathway of mitigating climate, where you send a plane high up in the stratosphere and throw throw sulfur dioxide and things like that, and you create aerosols up in the sky. That leads to overall cooling, but then there's negative impacts towards sort of again, like, I'm not as well informed as I should be, but there's implications to monsoons. There's implications for sort of agricultural yields falling down, like, Mount Pinatubo, which is sort of the famous quoted example. Again, IPCC's report also talks about this. Like, every century, there's a volcanic eruption that leads to sort of cooling down effects. So, yeah. So sorry, I've said quite a lot of things.
Thank you. Yeah, Saravanan.
So, I mean, I'd like to make a few comments. The immediate comment was solar geoengineering. I think research in solar geoengineering is probably not too bad, but it's really misunderstood, because solar geoengineering will lower the global mean temperature, yes, but it could cause a lot of harm in other places. And Dr. Divecha talked about lawsuits and litigation. One thing that solar geoengineering will do is trigger lots of lawsuits and litigation, because now you have something to blame. And so it's a very dangerous path in terms of deployment. Research, especially if it's done, there needs to be regulated research, and it probably will be international regulations for that. But given under those circumstances, limited research may be okay, but it's not going to solve problems. It's still in a research stage. One of the conclusions of the research might be that we don't want to do it. It's not that research is going to make it easy to do it, but we should be prepared for it, that we may not want to do it. I want to follow up on Dr. Divecha's comment about attribution. We can do attribution with models. It takes a lot of runs, as other folks have pointed out. I think the litigation thing is a bit of a loose end, because people are doing it because they can't get legislation passed to get that impact. I don't see the litigation going anywhere, because the damages of climate change are global and the litigations are in a particular nation. So I don't see how they'll apportion the damage globally versus regionally. But it's good PR. I think it serves that purpose. It puts pressure on the companies. I don't see it as actual legal end that's positive. But one of the things with attribution that came about recently, two particular cases, was there was a paper published by a Brazilian researcher, which pointed out that local politicians in Brazil are using climate change to make bad adaptation decisions, saying this flood happened because of climate change, so they won't make the hard decisions needed to avoid flooding. And this is an issue, and even the World Weather Attribution Organization, the leader of that, Frederico Otto, nowadays gives interviews saying, don't blame everything on climate change. That every disaster has multiple dimensions, and one of the dimensions is bad decision by human beings that made it much worse. And once the headline says climate change, people don't pay attention to bad decision making. So you can go too far in attributing climate change. Every disaster nowadays has a component that's climate change. Sometimes it could be over 50%, but sometimes it's less than 50%, and if that information is lost. So attribution is, people are tempering that, because sometimes you go overboard and you hide bad management decisions, or politicians hide behind. Final comment was, what can TIFR do? One thing is, as people have mentioned, it can, ICTS brings together meetings, and you can bring together diverse group who almost never meet. I'm not talking about two institutions in Bangalore who don't talk to each other, but two different groups of social scientists or physical scientists or something like that. That's the one. Other is what the previous comment I mentioned, things like AI, ML, or advanced statistics, advanced computing using GPU technology, which I think India is not that far ahead, because GPU technology and AI, ML go together. If a center like TIFR could easily take leadership in that area, and the other thing is possible industry partnership, because AI, ML is a hot topic in the industry. They could do things where they pick up that aspect of advanced technology. It could be a strategic decision by India to have an institution of excellence in AI, ML, and computing and advanced statistical techniques. And some of its applications could be climate, some could be other things. So that's a suggestion.
Thank you.
Hello, my name is Aditya Pujari. I'm a student of Rama. I wanted to ask the scientific panelists. So what I gathered from the 2-3 days here was that if we were to identify 1 or 2 key thrust areas that fundamental science should be focusing on, then like those 2 areas, from what I understood, were cloud microphysics and understanding aerosols, especially in the context of pollution. So like, can the panelists comment on this?
Yeah, Sandip, you can ask.
Yeah, so just carrying on that, this is outside research for me. So this was the first occasion to kind of learn more about climate science. I'm just wondering, typically I would not say this for a conference gathering, but this is an important problem. Should one of the outcomes be kind of listing of agreed, problems which we think are important for the country, both from scientific point of view? So we all agree that these are the 3 or 4 things which are topmost priorities. And then of course the impact, I guess we have to link everything that we solve to how it affects agriculture, migration, all the impacts, and the putting numbers to them, costs, etc. But in agreed sort of way, should we look to maybe do that out of this and similar gatherings? So it just concrete. It's like Clay's Mathematical Institute. When you come up with top 10 problems in mathematics, it directs the community.
Would the panelists like to respond to these 2 things?
Can I add something?
Go ahead. Yeah.
Yeah. Sandeep, I think when this meeting was called, I did not realize impact was not the issue. That's why I don't think any speakers spoke about impact. We didn't discuss. That's a whole new topic. And one could have spent 3 more days on impact issues. So I think we didn't discuss it. I mean, I always assumed it has more to do with science than impact. I'm sure neither Krishnan or others covered impact in their talks. So I think we should, if we want to do that, we've done separately. To me, what we can do is, if you want, based on whatever presentation discussion we had, we can talk about what scientific issues we should be focusing on. That could be a reasonable thing to do based on what we discussed in the last 3 days. Thank you.
Sure.
Yeah. Just to add to what Professor Jay said, yeah, so the most of at least my presentation, I was focusing on the science, not really going into the impacts. And with regard to the aerosol and cloud interaction, there is a program, and still it is there in IIT, known as CAPEX, Cloud Aerosol Interaction Precipitation Experiment. So they made several experiments, observations extensively over different parts of India to understand. A lot of data has been generated. But this is still a very, very challenging problem. In fact, some studies have shown that in the Western Ghats and the west coast of India, the clouds are mostly warm rain precipitation is very dominant. Not only west coast, many parts of India during the summer monsoon time. And how to parameterize the warm rain itself is unclear at a very fundamental level. Okay. So, and there is also role of large scale dynamics is very important. Mesoscale convective systems are involved. How do you segregate? So just telling that I will improve the aerosol microphysics. I mean, this is my loose thinking, please pardon me. So I'm going to improve the monsoon. Maybe I think it's a very tall claim to make. We have to really look at the monsoon in a much bigger picture. How to improve the convection at a very fundamental level, how the organization of mesoscale convective systems, these require very in-depth understanding. And so that's going to be an active area of research. And we cannot isolate that just doing aerosol microphysics is going to solve the problem.
Anyone else wants to respond to that? Other questions for the panelists? No, there weren't any online. If anybody has a question for the panelists. Okay, what about people in this
Rama,
room?
I'll just make a follow-up comment to Professor JS and Krishnan. I mean, in some sense, it seems to me that there are fundamental issues in science, but they should be governed by impact, right? You realize what's going to be important, and that tells you, okay, maybe aerosols are important because they're going to cause most impact on people. So that you can't really avoid that linkage, right? And it's probably good to spell it out very clearly.
No, I didn't understand. You mean impact on the precipitation? You mean, is that what you're saying? When you say impact is on the influence of aerosol on precipitation or something, is that what?
The impact on the country, on the population.
Yeah. See, there are two impacts. One is impact on the physical climate system. The other impact on the health. These two are, I want to keep them separate. So when we talk about climate, we are talking about the optical properties of the aerosols, how they are going to affect the radiation, how they are going to affect the clouds and the circulation and precipitation and so on. Now, the health is a completely different issue. It is going to depend on the size of the particle, whether you are talking about PM10 or PM2.5, how it is going to affect. These two are, so I tend to view them in a different way, these two. So impact, we have to be very clear what we mean by impact. We have to be more specific.
No, again, I mean, I kind of would ask myself that climate change is something going to cause disaster to the country and the world 20, 30, 40 years in a variety of ways now. First of all, is it correct? Is it not correct? In what ways will it happen? Let that guide the kind of research that I do.
Okay.
Maybe we need to have a better Earth system model so I can make these projections.
Yeah. So the common greenhouse gases are going to have, because of their very long lifetimes for centuries, the impact of the greenhouse gas is going to be there in the coming decades until even the end of the 21st century. Now, if we can mitigate, at least the message that comes out from the AR6 is, if the aerosol loading is mitigated, it has a positive influence on the monsoon. It can help the monsoon. So this is one. So in fact, the near term, for the near term projections, that is 2020 to 2040, how the aerosol, what policies the governments are going to take in the Asian countries, it can have an implication on the monsoon precipitation. And also, but having said that, internal variability in the system is also something that is also a source of uncertainty. And you could have natural forcings like volcanic eruptions that can happen anytime. And if there is one such big eruption like Pinatubo, it could have a very profound impact. So near term is a challenging issue, but definitely in the middle and long term, the effect of the global warming is going to dominate. That is what is the very clear message that comes out from the AR6.
Okay, so I would like to ask all the panelists to take about a minute if they have any final comments. So we'll go in the order that we're seeing on the screen. So Navroz first.
Thank you. I don't have very much by way of wrap up. I understand that the conversation is really focused on the fundamental science that TIFR can contribute. I do think that pushing the conversation over time into consideration of impacts and thereby into sort of thinking about the ways in which policy questions are phrased will ultimately make the research more relevant. And it would be useful to have maybe mechanisms for people at TIFR to keep in touch with some of these policy debates in such a way that they can be making those linkages backward and forward towards the policy questions. And there are, many tools and sources of information, and I'm sure Professor Ganpati can actually help with that. That would make sure those connections can be made in an iterative way as you think through your areas of research.
Those of us who don't know about these tools, would you be, if not now, at least willing to engage with us to help us build them? Because scientists don't know about these tools to make contact with public, at least not people like me. So we might need a little more guidance either just now or later on. Otherwise, the tendency is to go back to writing papers and doing great science, you know. So up to you, but perhaps later. But some guidance will be needed to make sure that we continue to connect and that connection grows, I think. Okay,
Please
thanks.
go ahead.
Thank you.
Spenta, go ahead and Deepti next.
Sorry. There is this whole issue of how we can influence government policy. I mean, in various areas actually that we work in. I mean, it's just so difficult actually to influence government policy because ultimately they make the policy. So may I request Navroz to make a few comments on that?
Would you like me to try? Well, the other panelists haven't. Well, it can be very short because frankly, I'm not sure that I have any particular alchemy on this. My sense is that the best way seems to be to well, there's two or three ways. One is to reframe the question itself, because often the government is asking the question in a very narrow way, and focusing on how you ask the question is useful. The second is to have a very precise answer ready for when the government finally gets around to asking the question, because at some point they will, and when they do, it will be on a 24 to 38, 48-hour cycle of requiring an answer. So being sort of thinking a little bit ahead is often the way. And then the third, which is the most cumbersome, is sadly, it is all network based. There are no institutional structures of communication. It is, whoever's number the Joint Secretary has on speed dial, which is a very unfortunate way, because all of that disappears when the Joint Secretary gets transferred, which is why a lot of people in Delhi spend an awful lot of time networking. And it's a very inefficient and in a way of doing things, and it doesn't actually build on itself over time, which is why I have strongly been advocating that we have to have some institutional structures that develop memory over time.
How do other countries do it?
They build institutional structures.
Deepti, please go ahead.
Okay, so, I just want to draw in from the conversations of my other panelists. And I think going forward, we have to keep in mind that with AI and ML and, our future generation taking a very, very significant interest in this whole situation, right? So when we talk to the youth, 18 to 25-year-olds, there is quite a bit of an awareness already, about the situation that they are going to be facing. I think it's very important for us to know that the young population is also quite keen to pursue, whether it is courses, whether it is parts of studying or seeking roles once they graduate in life, what kind of roles they want to take. I think it's very important for us to have that picture in mind, and therefore start thinking about how are we going to push the next generation towards how are we going to be handing down these knowledge reserves that we have built to the next generation, by giving them a very unbiased view of the situation and letting them take the studies forward through whatever technology they are going to be having in place. I think it's time for us to build that next generation of scientists, policy writers, communication specialists, activists, keeping that in mind, because this whole body of knowledge that we built so far should not be lost in transition. The same communication gaps and problems should not be encountered. And so I think it's time for us to think about this and put, like you said, talked about putting in place institutional structures, but we must either try to, let them understand how things are, or we should also be a little bit open towards accepting how they choose to communicate or what forms of technology they choose to communicate with, and then engage them at a much more deeper level. So I think drawing from the conversations, I really felt that going forward, this is what we must do. We must hand over our knowledge reserves quickly and at a faster pace to the next generation, so that they can equip themselves quite clearly to take on the challenge that they face.
Thank you. Professor Krishnan can go ahead.
Yeah, no, I have nothing specific to add. Yeah, I definitely agree. We need to build the next generation of, for example, the climate modelers or the climate scientists, talking from my field, in this field. So we need to build the next generation, a stronger generation, to take this forward. So that is my general, I agree with that proposition. Yeah.
Krishnan and Professor JS to comment on one issue which was raised by Dr. Krishnan in his talk, which is, Dr. Krishnan, you mentioned that you thought it would be a good idea to build a community.
Yes. Yeah. Yeah.
And can you please comment on what that will entail and how we could, what is the thinking on how to go ahead? And also Professor JS could also please.
Yeah. So one thing what we proposed in the, what we are thinking is there should be a community model, at least a climate model, just like the CESM from NCAR, which is a community model. If we can build a community model from India, which is an open source, which many people can work on, all the students, researchers, I think that is a great way to study the problem, enhance the scope of the climate modeling itself. And this is what we are thinking in the next few years. Probably there will be open source code. And and people can develop, of course, there will be a kind of master code at IITM, let us say. And other people, they can make their own developments, do the testing, sensitivity experiments and evaluations and so on. So that is one way to foster the development of the climate modeling activity in the country. And even perhaps we have to involve other outside international partners as well in this endeavor.
Anticipate as the time scale for it to become open source?
We have proposed to 2024-25. That's the kind of thing which I showed. It will take us some time.
Professor JS?
Krishnan, can I ask a clarification?
Yeah.
This community model, do you want it to be a regional or a global model?
It will be a global model.
But then won't it be a repetition of what already is done by NCAR for the last 2 decades? Because to me, what is required in India is a regional community model, which is the global model, most people cannot even run. You can run it in IITM, maybe IMT can run it, most people cannot run it. So what would be the advantage of such a model?
Yeah, the advantage of that model is if we want to do some very short experiment or a simplified experiment where you don't have to make very long runs. Maybe a very focused experiment to do a sensitivity analysis. If I want to examine the impact of this kind of aerosol on the precipitation, and people want to introduce a new scheme and test it. So various kind of, and this can help in the PhD research of some students. And it will also be a feedback for our own model development. NCAR CESM is definitely there. They have gone far ahead. They started long back. But from an Indian perspective, now that having put so much effort, why not we involve our own people and our own community and perhaps others to take it further? Because I don't know how many people we will be able to recruit in the coming years. So if we want to keep this activity alive, if we want to keep it going, this is one option. One way to go ahead is have a community model.
Yeah, sir, what I would like is the comment from Saravanan as to what kind of resource NCAR had to have to keep the community model going for so long. So that will help us to understand the problem.
Sure.
It's one word for it, it's money. That's the resource.
What two things NCAR did was it would fund the base funding at NCAR for the community model, but a certain portion of the funding would go to researchers at university to use that model. Similarly, a big computer for NCAR, it's 50-50. 50% is for NCAR, 50% is for universities. That's the only way the university people can run the community model, because they need the same class of computer that NCAR has. So a division of resources between NCAR and the university users, that's the only way it could do it. If NCAR had the whole computer, the university people couldn't run the model. Or if NCAR got all the money, the university people wouldn't have the money to work on problems related to it. So that's the model they used. Whether that's viable, that's a different question, but that's how they.
Shravan, what's the annual budget roughly, so that we get an idea what the ballpark?
I can give the number, but things are different in India. So I'm not, but my guess is like $20-30 million a year base funding.
Okay. Okay.
But that number would change a lot in different conditions.
Yeah.
You have final comments before we wrap.
Yeah, so I'll wrap it up. I'll just say a couple of things. One is a deepest comment about generational thing. I have colleagues, climate scientists now who are 50 plus years old, but they're starting on TikTok. I'd draw the line there. I'll do Twitter, but I'm not doing TikTok. But people are doing it because that's what the younger generation is doing. So that's interesting. I just want to say I'm very happy to be here. When I heard about this workshop at TIFR, I trained as a physicist, but I became a climate scientist. And I thought, what's TIFR doing about climate? I was curious. I thought, let me go find out. So I'm very happy that TIFR is getting interested in this area. I think the prestige they bring and the scientific depth they bring could help the whole climate area. And one of the things I think this meeting, it was nice, is that people are not siloed. I mean, you don't have climate scientists, communication experts, policy experts, all going to their own conferences and not talking to each other. And having more of this interaction, I think is great. It's been very nice getting the different perspectives from different people. Thank you.
Yeah, and we are very glad you came all the way. It was really nice of you. Okay, I think we've reached the end of this session. Thanks so much to all the panelists. It's been invigorating. I think like many of us will watch this recording again and again to go into all the finer points brought up. So thanks very much. And
thank you, Rama and team.
Yeah.
Thank you, everyone.
Thank you.
Yeah, thank you all. Thank you.